Hi, I'm Samesh, and I attend Inquiring Minds lecture series illustrated Special Relativity Through Its Paradoxes with speaker John Day Pillis. Just like the title says, Mr. Pillis illustrated the implications of special relativity through paradoxes. All pictures in this video, except for this first one, comes from Mr. Pillis's website animations. To understand special relativity, Mr. Pillis first talked about reference frames. Think of a reference frame as a coordinate grid with the x-axis as distance or space and the y-axis as time. In the Galilean reference frame, even if two objects are moving relative to each other, as long as their clocks are synchronized to start at the same time, they will continue to have synchronized time. This is the type of reference frame we have gotten used to using in Physics 1. However, as I found through my own research, the Galilean reference frame was disproved by experiments of measuring the speed of light at different reference frames. By the Galilean reference frame, the speed should have been different, but the speeds were surprisingly the same. Thus, the more relative nature of time is expressed through Lorentz reference frame, in which when two objects are moving relative to each other, the time desynchronizes with the faster object becomes shorter and having its clock move slower. This leads to two intriguing paradoxes described by Mr. Pillis. First is the twin paradox. Imagine two twins starting from the origin of a space-time coordinate system. Twin 1 stays on Earth and doesn't move, while twin 2 flies to the right on a rocket ship initially, then flies back. Surprisingly, twin 2 is a lot younger than twin 1 when he comes back to the same space location as twin 1. From the graph, you can see that twin 2's time is faster than twin 1's time initially. But as twin 2 reverses the direction of the spaceship towards twin 1 has to kind of age a lot relative to twin 1 suddenly in order for them to meet up with each other again in the same space at the same time. Thus we prove special relativity graphically through this paradox. The next paradox discussed by Mr. Pillis is the bug rivet paradox. Imagine two parallel plates parallel to the y-axis with a hole through the center of the left one. There is a butt directly to the left of the right plate. The distance between the two plates is equal to the length of a rivet. If a rivet initially outside the two plates is pushed at the speed of close to the speed of light through the hole in the left plate, when looking at the rivet as a stationary reference frame, the plates in the butt shrinks and the butt gets squished by the rivet. When looking at the plates as a stationary reference frame, the rivet shrinks and doesn't touch the butt, but then expands past the right plate and squishes the bug, but then returns to normal size when there is feedback given to the nail about what its size should be. The important implication of special relativity in this is that the future affects the past. Crazy, right? I know this is really difficult material to digest, so do your best and look on Mr. Pillis' website for more details. Thank you for your time.